Hello students, I am LS Nanda sir once again. This is my second video on my recently launched book, that is Golden Problems in Mathematics. If you haven't gone through the first video on this book, then please type Golden Problems in Mathematics Part 1 and you can watch that video. It contains detailed solutions of 10 challenging problems from this book. Now again, in this particular video, I am going to give you the detailed solutions of 10 another problems from this book. Now here is the first one. It says if for acute angle theta 27 sine cube theta plus 64 cos cube theta plus 180 sine theta cos theta equal to 125, then we are required to find the value of sine 3 theta plus cos 3 theta. Now first of all, if we look at these terms, we can notice these are perfect cubes, right? So what I do, I rearrange these terms and write like 27 sine cube theta plus 64 cos cube theta minus 125 plus 180 sine theta cos theta is equal to 0. If you are really thorough with your algebraic identities, then you can relate it with a algebraic identity, and that is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into inside the bracket a square plus b square plus c square minus ab minus bc minus c, right? Because this first term can be written as 3 sine theta whole cube, second can be written as 4 cos theta whole cube, this minus 125 can be written as plus minus 5 whole cube, and this 180 sine theta cos theta we can write as minus 3 into ABC. What is A? 3 sine theta. What is B? 4 cos theta. And what is C? Minus 5. Right? So now let me tell you an important concept connected with this identity, and that is if a cube plus b cube plus c cube minus 3abc is equal to 0, then what do we have? We have two things. Either a plus b plus c will be 0, or a is equal to b is equal to c. And this result holds when a, b, c are real numbers. Fine. And in our question, obviously 3 sine theta, 4 cos theta and minus 5 are real numbers. So we can apply this rule and say that either 3 sine theta plus 4 cos theta minus 5 is equal to 0, or 3 sine theta is equal to 4 cos theta is equal to minus 5. Fine. Now we know that the range of sine theta as well as cos theta is minus 1 to 1 closed interval. That means neither sine theta nor cos theta can be greater than 1 or less than minus 1. So now if we look at the second option which we have got, and that was 3 sine theta equal to 4 cos theta equal to minus 5, then this is clearly not possible. Why not possible? Because if I find the value of sine theta from this, it is going to be minus 5 by 3, and cos theta is going to be minus 5 by 4. Both of them are not possible because they are not coming in the prescribed interval, right? So that means now we are just left with the one possibility, and that is 3 sine theta plus 4 cos theta has to be equal to 5. Fine. Now in order to get the value of theta, I am dividing the entire equation by 5. So we get 3 sine theta upon 5 plus 4 cos theta upon 5 is equal to 1. Let's assume this 3 upon 5 as sine of some angle, and let's say that angle is alpha. So that means sine alpha is 3 upon 5. If sine alpha is 3 upon 5, what should be the value of cos alpha? It will be 4 upon 5. So that means now this equation can be written as sine alpha into sine theta plus cos alpha into cos theta is equal to 1. Or in other words, I can say cos of theta minus alpha is equal to 1. Now what is 1? 1 can be written as cos 0. So that means ultimately we get theta is equal to alpha. Fine. You can notice from this equation, this particular one, that if I divide sine alpha by cos alpha, I'll be getting the value of tan alpha as 3 by 4. And this alpha is now an acute angle tan inverse 3 by 4. Since we wanted to find a acute angle value of theta, so theta will be obviously equal to alpha. That means theta is equal to tan inverse 3 upon 4. Fine. Or in other words, I can say tan theta as 3 by 4. Now let me make a small triangle, right triangle, and this angle is theta. So I can write the values like 3, 4 and 5 to get cos theta as 4 upon 5 and sine theta as 3 upon 5. Fine. Now we are required to find the value of sine 3 theta plus cos 3 theta. Students, you must be knowing that the identity for sine 3 theta is 3 sine theta minus 4 sine cube theta, and for cos 3 theta it is 4 cos cube theta minus 3 cos theta. So just put in the values obtained and you will be getting the final answer. So here we go. This is 3 sine theta, means 3 into 3 by 5 minus 4 sine cube theta. Similarly, cos 3 theta is going to be 4 into 4 upon 5 cube minus 3 cos theta. So that means 3 into 4 upon 5. Now just simplify the values. You'll be getting 9 upon 5 minus this is 27 into 4. So it is 108 upon 125 plus 64 into 4, 256 upon 125 minus 12 upon 5. So finally, if we just take the LCM as 125, then in the numerator, if you add all the terms, you'll be getting 73. Why 73? Because it is 225 minus 108 plus 256 minus 12 into 25. So that is 300. So when you will do the calculations, finally you are going to get 73 upon 125. So hence B option is the correct one. Now we move to our second question. Now students, this is another interesting problem on trigonometry that I have created. The question says if A and B are acute angles such that sine square A plus cos square A plus tan square A plus cot square A plus secant square A plus cosecant square A is equal to 7. And similarly sine square B plus cos square B plus tan square B plus cot square B plus secant square B plus cosecant square B is equal to 31. Then we have to find the value of sine square A plus B plus cos square A minus B. Now why I'm saying it's an interesting problem, because it involves all the trigonometric functions. All the possible 6 trigonometric functions are there in this question. Now to solve this problem, what should we do? First of all, I am generalizing this expression. I am just, in place of A and B, I am just putting x. Sine square x plus cos square x plus tan square x plus cot square x plus secant square x plus cosecant square x. First of all, let's simplify this expression and see what finally comes. Now we know that sine square x plus cos square x is 1, right? We can replace secant square x by 1 plus tan square x and cosecant square x by 1 plus cot square x. So it means 1 plus 1 plus 1 3 times. It becomes 3 plus 2 tan square x plus 2 cot square x, right? Now this can further be written as 3 plus 2 times Now what I am doing, I am putting tan x as sin x upon cos x and cot x as cos x upon sin x. So it will become further sin square x upon cos square x plus cos square x upon sin square x. Now just take the LCM to simplify this expression further. We get in the denominator sin square x cos square x. In the numerator we will be getting sin x power 4 plus cos x power 4. Fine. Now you must be knowing that sin x power 4 plus cos x power 4 can also be written as sin square x plus cos square x whole square minus 2 sin square x cos square x. Which identity I am using over here? I am using a square plus b square can be written as a plus b whole square minus 2ab. And in this problem, I am treating a as sin square x and b as cos square x, right? I hope you'll be able to understand this. So here, I am just putting it like this. And denominator is going to be same as sin square x into cos square x. Now we move further. We'll be putting the value of sin square x plus cos square x as 1. Now this expression can be written as 3 plus 2 into, inside the bracket we'll be getting 1 minus 2 sin square x cos square x divided upon sin square x into cos square x. What I have done? I have put sin square x plus cos square x as 1 because it's a direct identity. Now further solve it to get 3 plus 2 upon sin square x cos square x minus 4, right? Because this sin square x cos square x and sin square x cos square x will cancel each other. Now what I am doing, I am writing this as this second term 2 upon sin square x cos square x. What I am doing in this, I am multiplying up and down by 4. Why? Because when I multiply up and down by 4, in the numerator I will be getting 8 and in the denominator I will be writing this as 2 sin x cos x whole square. Fine? Because we know that 2 sin x cos x is nothing but sin 2x. So now this becomes 8 into cosecant square 2x minus 1. So students, now you can see that big expression has finally been reduced to 8 cosecant square 2x minus 1. Fine. So now what I am doing to solve the first equation, I am just replacing x as a in this. So this is our first equation. It will become 8 cosecant square 2a minus 1 equal to 7. Why 7? Because the value was given as 7. So now cosecant square 2a becomes equal to 8 upon 8, which is nothing but 1. And it has been given that a is an acute angle. So further I can write sin 2a as just 1 or 2a equal to pi by 2, because at pi by 2 sin is equal to 1. So a finally comes out to be pi by 4 or 45 degree. Fine. Now similarly, I am solving the second equation as 8 cosecant square 2b minus 1 equal to 31. So that means from here we'll be getting cosecant square 2b equal to 32 upon 8 or 4. So that means sin 2b can be written as 1 upon 2. Why 1 upon 2? Because when we take the square roots on both sides, the value of cosecant 2b becomes 2. And since sin 2b is the reciprocal of cosecant 2b, so therefore sin 2b is equal to 1 upon 2. And we are given that b is an acute angle. So now 2b can be written as pi by 6 because the value of sine at pi by 6 is half. Now the value of 2b is equal to pi by 6, implying b is equal to pi by 12 or 15 degree. So now we have got the value of a as pi by 4 and b as pi by 12, and we are required to find the value of the expression sine square a plus b plus cos square a minus b, right? So now just put in the values of a and b to get the answer. It becomes sine square pi by 4 plus pi by 12 plus cos square pi by 4 minus pi by 12. So finally I can rewrite this as sine square 45 plus 15 degree, it is simply 60 degree. So we can directly write pi by 3, or you can even take the LCM and simplify it, plus cos square 45 minus 15, it is 30 degree. So this is pi by 6. And we know that the value of sine pi by 3 is root 3 by 2. So it is the square of root 3 by 2 plus again the square of root 3 by 2, because cos 30 degree or cos pi by 6 is also equal to root 3 by 2. So now this is 3 by 4 plus 3 by 4. Finally it is 3 by 2. So hence D option is the correct one. Now students, we move to the third problem. Now students, this is our third problem. This is a fantastic question on the topic of sequences and series. In this problem, as you can see, we have to find the product of two series, and both of these series are neither AP nor GP, neither they are arithmetico-geometric progression. But when we look at these two series carefully, we can say that both of them are quite similar to AGP. Why I'm saying this? Because if we look at S1, then S1 can be written as 1 into 1 by 2 plus 8 into 1 upon 2 square plus 27 into 1 upon 2 cube plus 64 into 1 upon 2 to the power 4 plus 125 into 1 upon 2 to the power 5 and so on till infinity, right? Let's call this equation as the first equation. Now you must be knowing that in the case of AGP, the terms of AP get multiplied with corresponding terms of a GP. But in this case, GP 1 by 2, 1 by 2 square, 1 by 2 cube, 1 upon 2 to the power 4 and so on is being multiplied with consecutive cubes of natural numbers. That is 1 cube into 2 cube into 3 cube into 4 cube and so on. Now students, you can note here, whenever you have to find the sum of such a series where a GP is being multiplied with consecutive powers of consecutive natural numbers like consecutive cubes, consecutive squares or consecutive fourth powers and so on, then the treatment to solve for the sum of such a series remains almost the same as we used to do in the case of AGP. Now I'm going to explain it. We'll be multiplying this series with the common ratio of this GP involved, that is 1 by 2 on both sides, to get S1 by 2 equal to 1 upon 2 square plus 8 upon 2 cube plus 27 upon 2 to the power 4 and so on. But what I am going to do, I will be shifting these terms to one place on the right hand side. That is 1 upon 2 square I will be writing just below 8 upon 2 square. Then I will be writing 8 upon 2 cube below 27 upon 2 cube. Then I will be writing 27 upon 2 to the power 4 plus 64 upon 2 to the power 5 and so on till infinity, right? Let's call this equation as second. Now just subtract both of them. That is, subtract the second equation from the first one. So you'll be getting S1 by 2 equal to 1 by 2 plus 7 upon 2 square plus 19 upon 2 cube plus 37 upon 2 to the power 4 plus 61 upon 2 to the power 5 and so on till infinity. Now we move ahead. Now students, with this series again I am going to repeat the same process, that is s1 upon 2 equal to 1 upon 2 plus 7 upon 2 square plus 19 upon 2 cube plus 37 upon 2 to the power 4 plus 61 upon 2 to the power 5 and so on till infinity. This we have already got. Now I will be multiplying both sides of this series with 1 by 2 again to get a similar series, and that is going to be 1 upon 2 square plus 7 upon 2 cube plus 19 upon 2 to the power 4 plus 37 upon 2 to the power 5 and so on till infinity. Now let's say this is the third equation and this is the fourth one. Now I'll be subtracting the fourth equation from the third one. This is why I shifted the terms on the right hand side one place towards right, because when we subtract it will become easier. 7 minus 1 is 6, 19 minus 7 is 12 and so on. That means now we'll be getting upon subtraction s1 by 4 equal to 1 by 2 plus 6 upon 2 square plus 12 upon 2 cube plus 18 upon 2 to the power 4 plus 24 upon 2 to the power 5 and so on till infinity. Fine. Now students, if you have done AGP, now I think you will be able to understand my point of view, and that is if I subtract or just shift half onto the left hand side, I'll be getting s1 upon 4 minus half equal to nothing but a arithmetico-geometric progression, and this is 6 upon 2 square plus 12 upon 2 cube plus 18 upon 2 to the power 4 plus 24 upon 2 to the power 5 and so on, right? In this AGP, what is the GP? GP is 1 upon 2 square, 1 upon 2 cube, 1 upon 2 to the power 4 and so on. And which terms are in AP? It is 6, 12, 18, 24 and so on. Fine. Now you can easily solve this and get the final answer. Now students, we have s1 upon 4 minus half equal to 6 upon 2 square plus 12 upon 2 cube plus 18 upon 2 to the power 4 plus 24 upon 2 to the power 5 and so on till infinity. So I'm now directly adopting the technique of arithmetic geometric progression, and what is that? I will be again multiplying both sides with 1 upon 2 to get a new series, like it is going to be 6 upon 2 cube plus 12 upon 2 to the power 4 plus 18 upon 2 to the power 5 and so on till infinity. Now let's consider this is the fifth equation and this is the sixth one. Just subtract the sixth equation from the fifth one. So you'll be getting 1 upon 2 into s1 by 4 minus half equal to 6 upon 2 square plus 6 upon 2 cube plus 6 upon 2 to the power 4 plus 6 upon 2 to the power 5 and so on till infinity. And this is nothing but a direct GP. So take out 6 common. Inside you are going to get 1 upon 2 square plus 1 upon 2 cube plus 1 upon 2 to the power 4 plus 1 upon 2 to the power 5 and so on till infinity. Now in the bracket it is just a infinite GP with first term as 1 upon 4 and common ratio as 1 upon 2. So I'm just directly applying the formula A upon 1 minus R. So it becomes 6 into, this is going to be just half, because 1 upon 4 into 2. So this becomes 3, right? Now we move ahead. Now students, we are having 1 upon 2 into s1 upon 4 minus half is equal to 3. So that means S1 upon 4 minus half is equal to 6, or S1 upon 4 is equal to 6 plus 1 by 2. So this becomes 13 upon 2. So finally S1 can be written as 4 into 13 by 2, that is 26. Right? Now we move towards finding the value of S2. Now to solve for S2, we are having S2 as 1 upon 3 plus 4 upon 3 square plus 9 upon 3 cube plus 16 upon 3 to the power 4 plus 25 upon 3 to the power 5 and so on till infinity. Right? Now to find the value of this series, again we have to follow the same process. That is, now this time I am going to multiply both sides with 1 upon 3. So I'll be getting on the right hand side a series of 1 upon 3 square plus 4 upon 3 cube plus 9 upon 3 to the power 4 plus 16 upon 3 to the power 5 and so on till infinity. Now just subtract these two equations to get 2s2 by 3 equal to 1 upon 3 plus 3 upon 3 square plus 5 upon 3 cube plus 16 minus 9, it is 7 upon 3 to the power 4 plus 25 minus 16, it is 9 upon 3 to the power 5 and so on till infinity. Now students, you can clearly notice if I just subtract 1 by 3 on both sides, I'll be getting 2s2 by 3 minus 1 by 3 equal to, now this series on the right hand side is nothing but a what? It's a AGP. 3 upon 3 square plus 5 upon 3 cube plus 7 upon 3 to the power 4 plus 9 upon 3 to the power 5 and so on till infinity. Right? Now it's very clear how to move ahead. Now we have 2s2 upon 3 minus 1 upon 3 equal to 3 upon 3 square plus 5 upon 3 cube plus 7 upon 3 to the power 4 plus 9 upon 3 to the power 4 and so on till infinity. Right? So what I'm going to do now, I will be multiplying both sides with 1 upon 3 again, because now it's a direct AGP, and then we'll be subtracting both the equations. So now I'm going to get 3 upon 3 cube, which I will be just writing below 5 upon 3 cube. Similarly, the next term is going to be 5 upon 3 to the power 4 plus 7 upon 3 to the power 5 and so on till infinity. Now just subtract these two equations to get 2 by 3 into 2s2 by 3 minus 1 upon 3 is equal to 3 upon 3 square plus 2 upon 3 cube plus 2 upon 3 to the power 4 plus 2 upon 3 to the power 5 and so on till infinity. Right? Now this is 2 upon 3 into 2s2 by 3 minus 1 by 3 equal to, this is 3 upon 3 square, so this is just 1 upon 3 plus, now starting from 2 upon 3 cube plus 2 upon 3 to the power 4 and so on, these terms are just forming a direct geometric progression. So what I'm going to do, I'm just putting a bracket, and inside the bracket I am just writing the sum of this geometric series, which is a infinite geometric series, and first term is 2 upon 3 cube. I am again using the formula a upon 1 minus r, and the common ratio is 1 upon 3. So in the denominator is going to be 1 minus 1 by 3. Right? So the value becomes 1 upon 3 plus 2 upon 27 into, in the denominator we had 2 upon 3 So it will get reciprocated to become 3 by 2. So now this is 1 upon 3 plus 1 upon 9, or LCM is 9, and this is 4 upon 9. Now we have 2 by 3 into 2s2 by 3 minus 1 by 3 equal to 4 upon 9. So 2 cancels with 4 to give us 2, and 3 cancels with 9 to give us 3. So it becomes 2s2 by 3 equal to 1 upon 3 plus 2 by 3, and 1 by 3 plus 2 by 3 is just 1. So from here we get s2 is equal to 3 by 2, right? We already had s1 as 26. So what would be the value of s1 into s2? It is just 26 into 3 by 2, or just 39, right? So C option is the correct one. Now students, this is the next problem that I'm going to take up, and as you can see, it's a question based on the concept of logarithms. If you are familiar with all the laws of logarithms, then this problem can become easy for you. In this particular question, we are going to use one very important property of logarithms, and that is log a to the base b is nothing but 1 upon log b to the base a. Actually, this particular property has been derived from a base changing formula of logarithms, and that is log a to the base b divided upon log c to the base b is equal to log a to the base c, right? Now in this problem, we can clearly see there are terms involving log 2 to the base 3 and its reciprocal, that is log 3 to the base 2. Similarly, log 2 to the base 5 and its reciprocal log 5 to the base 2. Then we have log 2 to the base 7 and its reciprocal log 7 to the base 2. Fine. So what I'm going to do, I'm putting log 2 to the base 3 as A, log 2 to the base 5 as B, and log 2 to the base 7 as C. Fine. Now our problem will become x is equal to log of a to the base 2 divided upon log of 1 upon a to the base 3. Why 1 upon a? Because I have just told you that log 2 to the base 3 is the reciprocal of log 3 to the base 2 if we use the above property. Now plus we have log b to the base 2 divided upon log 1 upon b to the base 5. Then further plus log c to the base 2 divided upon log 1 upon c to the base 7. Fine. Now we move further. Now students, there is another property of logarithms. It says log m to the power p to the base a can be written as p into log m to the base a. Fine. So that means now we can write x as log of a to the base 2 divided upon, in the denominator we had log 1 by a to the base 3. Now it can be written as minus log a to the base 3. Why minus? Because 1 by a can be written as a to the power minus 1, and by using this property I have taken minus out. Now similarly, in the second term we are going to have log b to the base 2 divided upon log 1 by b to the base 5, which can be written as minus log b to the base 5. Similarly, in the third term we have log c to the base 2 divided upon log 1 by c to the base 7, so which can be written as minus log c to the base 7. Fine. Now finally I can write down minus out. In the bracket we are going to have log a to the base 2 divided upon log a to the base 3, which can further be written as, if I use the property again, I can rewrite the given expression as log 3 to the base a divided upon log 2 to the base a. Fine. Similarly, in the second term, I can rewrite it as log 5 to the base b divided upon log 2 to the base b. And similarly, in the third term, I can rewrite it as log 7 to the base c divided upon log 2 to the base c. Clear? Now finally, again using base changing formula, which I told you when I started the question, it will become minus bracket log 3 to the base 2 plus log 5 to the base 2 plus log 7 to the base 2. Fine. And now we are going to use one very basic property of logarithms. And what is that? Log m to the base a plus log n to the base a can be written as log mn to the base a. Fine. So if we combine all these terms by this property, we can rewrite this as log of 3 into 5 into 7. So that is 15 into 7 or 105 to the base 2. Fine. Now this finally becomes minus log 105 to the base 2, or we can again rewrite this as log of 1 upon 105 to the base 2. Now students, if you are aware about the basic concept or basic definition of logarithms, then you must be knowing now I can convert this back to exponential form and rewrite this expression as 2 to the power x equal to 1 upon 105. So this is our required answer. Fine. Now this is our next problem. As you can see, it's a question based on the concept of indefinite integration. If you have done good practice on the concept of integrals, then you must be knowing in order to solve such kind of integrals, we need to put or substitute one part of the integrand as t. Now if in this question, if I consider 5 minus x upon 5 plus x as t, then after doing differentiation of this expression, I will be getting 5 plus x whole square in the denominator. Whereas in this particular problem, I am having 5 minus x whole square in the denominator. So that means substituting 5 minus x upon 5 plus x as t is not going to serve my purpose. Rather, I should put the reciprocal of this, that is 5 plus x upon 5 minus x as t. Because when I differentiate both sides with respect to x, I will be getting 5 minus x whole square in the denominator because I am applying quotient rule, and in the numerator I will be getting 5 minus x into 1 minus 5 plus x into minus 1 dx equal to dt, right? So that means if I solve the numerator now, I will be getting 10 upon 5 minus x whole square into dx equal to dt. So that means if I consider the given integral as I, then now I will become integral. Since dx upon 5 minus x whole square is equal to dt upon 10, so now the integral becomes dt upon 10 into t to the power minus 1 by 3. Why I am putting minus 1 by 3? Because I have substituted reciprocal of 5 minus x upon 5 plus x as t. Fine. So it is going to be t to the power minus 1 the whole cube root. Now it becomes t to the power minus 1 by 3. So now if I take out 1 by 10, inside I am going to get t to the power minus 1 by 3 dt. Just apply the formula of integration. You will be getting 1 by 10 into t to the power 1 minus 1 by 3, which is 2 by 3 divided by 2 by 3 plus c. Or in other words, we will be getting 3 upon 20 into t to the power 2 by 3 plus c. So now our question is almost solved. We just need to replace t by its value in terms of x. So now the final answer is 3 upon 20 into 5 plus x upon 5 minus x whole to the power 2 by 3 plus c. So that means C option is the correct one. Now we move to our next problem. Now students, this is an interesting problem based on the concept of vectors. It's written, let v1, v2, v3 be three vectors such that mod v1 equal to 1, mod v2 equal to 2, mod v3 equal to 3, and square of mod of v1 plus v2 minus v3 plus square of mod of v2 plus v3 minus v1 plus square of mod of v3 plus v1 minus v2 is equal to 20, and we are required to find the value of mod of v1 plus v2 plus v3. Now if you are well aware about the properties of dot product of vectors, then you can easily solve this problem. Now we know that a dot a can be written as mod a square, right? So using this we can write square of mod of v1 plus v2 minus v3 equal to v1 plus v2 minus v3 dot v1 plus v2 minus v3. Fine. If we use the properties of dot product and solve it further by using distributive law of vectors, we'll be getting finally mod v1 square plus mod v2 square plus mod v3 square plus 2 v1 dot v2 minus 2 v2 dot v3 minus 2 v1 dot v3, right? Similarly, you can simplify the other two expressions like square of mod of v2 plus v3 minus v1 will come as mod v1 square plus mod v2 square plus mod v3 square plus 2 v2 dot v3 minus 2 v1 dot v2 minus 2 v1 dot v3, right? Now we move further. Now similarly we can write square of mod of v3 plus v1 minus v2 as mod v3 square plus mod v1 square plus mod v2 square plus 2 v3 dot v1 minus 2 v3 dot v2 minus 2 v1 dot v2, right? Now if we add all these three expansions, finally we can write mod of v1 plus v2 minus v3 square plus mod of v2 plus v3 minus v1 square plus mod of v3 plus v1 minus v2 square equal to 3 times mod v1 square plus mod v2 square plus mod v3 square, right? Minus 2 v1 dot v2 minus 2 v2 dot v3 minus 2 v3 dot v1. I have taken out 2 common to make it look easier. Now the value of this expression is given to us as 20. Moreover, we are given the value of mod v1 as 1, so that means this is 1. mod v2 as 2, so this is 4, mod v3 as 3, so this is 9. Fine. So what do we get? We'll be getting 3 into 14 minus 2 v1 dot v2 plus v2 dot v3 plus v3 dot v1 equal to 20. Now if we solve this expression, we'll be getting the value of 2 times v1 dot v2 plus v2 dot v3 plus v3 dot v1 as 42 minus 20, so which is 22, right? Now we call this equation as equation 1 because we'll be using this value further. Now from equation 1, we are having the value of 2 times v1 dot v2 plus v2 dot v3 plus v3 dot v1 as 22, right? This is our equation 1. And we are finally required to find the value of mod of v1 plus v2 plus v3. So what I am doing, first of all, I am finding the value of its square. Why? Because square of mod v1 plus v2 plus v3 can be written as v1 plus v2 plus v3 dot v1 plus v2 plus v3. And if we solve it further by using distributive law of vectors, we'll be getting mod v1 square plus mod v2 square plus mod v3 square plus 2 times v1 dot v2 plus v2 dot v3 plus v3 dot v1. Fine. Now we know this is 1, this is 4, this is 9, and from equation 1 we can put the value of this expression as 22. So that means finally this value becomes 22 plus 14 or 36. So finally we can say mod of v1 plus v2 plus v3 is just equal to 6. So D option is the correct one. Now we move to our next problem. Now students, this is really a nice question on coordinate geometry that I have created. The question says, if an equilateral triangle of area delta is enclosed by 3 straight lines whose equations are given as 2x plus y minus 3 equal to 0, m1x minus y minus m1 plus 1 equal to 0, and m2x minus y minus 3 m2 minus 3 is equal to 0, then we have to find the value of delta upon mod of m1 minus m2. Now such kind of questions are very much suitable from JEE main or JEE advanced point of view. Now how should we start with this? Let's make a triangle first. It's an equilateral triangle. I'm calling this triangle as ABC. Now suppose the equation of AB is 2x plus y minus 3 is equal to 0. Equation of BC I'm taking as m1x minus y minus m1 plus 1 is equal to 0. And the equation of AC as m2x minus y minus 3m2 minus 3 is equal to 0. Right? Now first of all, let's solve the equation of AB with equation of BC to get the coordinates for P. Now I will be using substitution method. I will take out y as 3 minus 2x from AB and will put in the equation of BC. So you'll be getting m1x plus 2x minus 3 minus m1 plus 1 is equal to 0. Now m1, if we take out common from these two terms, we'll be getting in the bracket x minus 1 plus 2x minus 2 is equal to 0. X minus 1 is straight away common. We'll be getting m1 plus 2 is equal to 0. or we get x is equal to 1 because m1 cannot be equal to minus 2. Why minus 2? Because the equation of AB is 2x plus y minus 3 is equal to 0. So its slope is itself minus 2. And if BC is intersecting AB, then it cannot be having the same slope as that of AB, right? So that's why x is equal to 1. If I put x equal to 1 now in equation of AB, I'll be getting y again as 3 minus 2x, that is 3 minus 2, which is again 1. So the coordinates of B finally come as 1, 1, right? Similarly, now we can find the coordinates for A. Now we'll be finding the coordinates for A in similar way by mutually solving the equations of AB and AC. Equation of AB was 2x plus y minus 3 is equal to 0, and equation of AC is m2x minus y minus 3m2 minus 3 is equal to 0. Equation of BC is m1x minus y minus m1 plus 1 is equal to 0, right? Now, when I put the value of y as 3 minus 2x in the equation of AC, I will be getting m2x plus 2x minus 3 minus 3m2 minus 3 is equal to 0. Or in other words, m2 into inside the bracket x minus 3 plus 2x minus 6 will be equal to 0. If I take x minus 3 common now, I will be getting m2 plus 2 inside the bracket. Now we know that m2 cannot be equal to minus 2. It's not possible, right? Because AC is intersecting with AB and the slope of AB is itself minus 2. So the slope of AC cannot be equal to the slope of AB. So that means x will be equal to 3 only. And if x is equal to 3, when I put this value in the equation of AB, I will be getting 6 plus y minus 3 is equal to 0, or in other words, y will be equal to minus 3. So that means the coordinates of A will be 3, minus 3, right? Now we have got the coordinates for A and B. Students, do not try to get the coordinates for C because you won't be able to solve them in terms of integers. You'll be getting them in terms of m1 and m2, and it's not of any use right now. Now we have to concentrate on the value of delta of mod of m1 minus m2. Now, to find the value of delta upon mod of m1 minus m2, first of all, I'll be getting the value of delta. Now, since it's an equilateral triangle, so delta will be equal to root 3 by 4 a square, where a represents the side of this triangle. And side we can easily find by using distance formula. So I can write a square equal to 3 minus 1 whole square plus minus 3 minus 1 whole square, which finally comes as 4 plus 16 or equal to 20, right? So that means delta will be equal to root 3 by 4 into 20, or it's just 5 root 3. Fine, 5 root 3 square units. Now we have found the value of delta. Now our next task and most important task is to find the value of mod of m1 minus m2. Now students, if we look at the figure of the triangle and consider its equations, then you can clearly see both the lines AC and BC, they are making 60-degree angle with AB because it's an equilateral triangle, and the slope of BC is m1, whereas the slope of AC is m2. Fine. So now I can consider a general variable m, which will have two values as m1 and m2. such that both of these values will satisfy mod of m plus 2 upon 1 minus 2m equal to root 3. Why I'm writing this? You must be aware of the formula that whenever two lines intersect each other at an angle theta, and if one line has the slope m1, another has the slope m2, then tan theta can be written as mod of m1 minus m2 upon 1 plus m1 m2, where theta is the acute angle formed between these two lines. Suppose you want to get the obtuse angle as well as acute angle, then you can remove the modulus sign and write tan theta equal to plus minus m1 minus m2 upon 1 plus m1 m2. Fine. But right now the angle which is available to us is just 60 degree. That is the acute angle. So I am taking modulus sign over here. Now what I am going to do, I will be squaring this equation to get m plus 2 whole square equal to 3 into 1 minus 2m whole square. And since it's a quadratic equation in terms of m, obviously it will be having two roots, and those two roots are represented by m1 and m2 as per our question. Fine. I hope you must be getting this point. This is an important step of this question. Now we'll be getting m square plus 4m plus 4 equal to 3 into 4m square minus 4m plus 1. Finally, I can write 12m square minus 12m plus 3 over here. And on this side, I will be getting m square plus 4m plus 4. Let's solve this equation. We'll be getting 11m square minus 16m minus 1 is equal to 0. There is no need to get the values for m1 and m2 because it may be little complicated. I am just interested in getting the value of mod of m1 minus m2. To get the value of mod of m1 minus m2, first of all, I am writing this formula m1 minus m2 whole square equal to m1 plus m2 whole square minus 4m1 m2. It's a simple algebraic identity. Now, since m1 and m2 are the roots of this particular quadratic equation, so m1 plus m2 is nothing but the sum of its roots, which is just 16 upon 11. Fine. m1 plus m2 is 16 upon 11, and m1 into m2 is equal to minus 1 upon 11. Fine. So just put these two values in this equation. We'll be getting 16 upon 11 whole square, that is 256 upon 121 plus 4 upon 11. Finally, when we take the LCM, we'll be getting 121 in the denominator, and in the numerator it is going to be 256 plus 44, so it's 300. Fine. Now students, our question is almost done now. We earlier found the value of delta as 5 root 3, and now we have got m1 minus m2 whole square equal to 300 upon 121. So that means if I take the square root on both the sides, I will be getting mod of m1 minus m2 equal to 10 root 3 divided upon 11. So obviously delta upon mod of m1 minus m2 is now 5 root 3 divided upon 10 root 3 by 11, or this is just 11 upon 2. So B option is the correct option. Now students, this is a fantastic problem based on the concept of geometry of complex numbers. Such kind of questions are very much suitable from JEE advanced point of view. The question says, if z1, z2, z3 are three complex numbers such that mod of z1 minus z2 is equal to 4, mod of z2 minus z3 is equal to 6, and mod of z3 minus z1 is equal to 8, then we have to find the value of this big expression involving all the three complex numbers. Now, if you are familiar with the basic concept of geometry of complex numbers, then you must be knowing that if two complex numbers are present in Argand plane such that Z1 complex number is at point A and Z2 complex number is at point B, then the distance AB will be given by mod of Z1 minus Z2. Now this basic concept we are going to use in this particular question. Moreover, just by seeing these three values, we can conclude that these 3 points Z1, Z2, Z3 or three complex numbers Z1, Z2, Z3 will form a triangle. What I am doing here, I am representing Z1 by point A, Z2 by point B and Z3 by point C. So that means this ABC will be a triangle. Why I am saying this? Because these three values 4, 6 and 8, they are following triangle inequality. So that means these 3 points Z1, Z2, Z3 cannot be collinear, right? Now I'm just writing their lengths AB, BC and CA. Now when we look at this big expression which we have to evaluate, one thing comes to our mind, and that is this is the point I am taking as the centroid. I hope you must be knowing the meaning of centroid. Centroid is the point of concurrency of three medians. I am making three medians AD, BE and CF. Suppose they are intersecting at the point G called centroid. Now from basic geometry we know that G will be represented by the complex number Z1 plus Z2 plus Z3 by 3. Now suppose I find the value of AG. What I am doing? I am finding the distance between the points A and G. What happens? According to this basic concept, what I will be getting? I will be getting mod of Z1 minus Z1 plus Z2 plus Z3 by 3, right? I want to create an expression very similar to the given expression. This is why I am doing this. Now AG, when we simplify, we will be getting 3Z1 minus Z1 minus Z2 minus Z3, or mod of 2Z1 minus Z2 minus Z3 whole divided by 3, right? I hope now you can make the comparison between this expression and the given expression. We are very close towards getting the value of this expression. Now I can say mod of 2Z1 minus Z2 minus Z3 is nothing but 3AG. Fine. Now we move further. Now similarly, we can write 3BG is equal to mod of 2Z2 minus Z1 minus Z3, and similarly 3CG will be equal to mod of 2Z3 minus Z1 minus Z2. So that means 2Z1 minus Z2 minus Z3 square plus mod of 2Z2 minus Z1 minus Z3 square plus mod of 2Z3 minus Z1 minus Z2 square is nothing but 9 times inside the bracket AG square plus BG square plus CG square. Fine. And we know that the centroid of a triangle divides every median in the ratio 2:1. So that means AG can be written as 2/3 of AD. Similarly, BG can be written as 2/3 of BE and CG can be written as 2/3 of CF. Fine. So this is nothing but 4 times AD square plus BE square plus CF square. Fine. I hope it must be clear to you people. Now at this stage I am using a very important theorem of plane geometry, and this theorem is called Apollonius theorem. And the theorem states, in any triangle, if AD is the median, in triangle ABC, if AD is the median, then we can write AB square plus AC square equal to 2 times AD square plus BD square. And we can write similar results for other two medians as well. Now when we get different equations for other medians also and then add those equations and simplify them, we finally reach at a very important result, and that is 3 times AB square plus BC square plus CA square is nothing but 4 times AD square plus BE square plus CF square. You can easily find this result in reference books of class 10th. This is a very important result if you are really preparing for different Olympiads and competitions. Now students, it is very clear from this equation 1 and 2 that the given expression is nothing but 3 times AB square. Now what was AB? It was 4 square. What was BC? BC was 6, so it is 6 square, and CA was 8, so it is 8 square. And this is our final answer now, 3 times 16 plus 36 plus 64. So this is 116. And finally 3 into 116 is just 348. Fine. So C option is the correct one. Now it was a difficult as well as a very interesting problem. Now we move to our next question. Now students, this is an interesting problem from the topic of three-dimensional geometry. The question says, if point P, whose coordinates are k, k minus 1, k minus 2, is situated at a perpendicular distance of 10 upon 3 root 5 units from a plane containing 3 points A, B, C, where A is 1, 2, 1, B is minus 1, 3, 4, and C is 1, 0, and 5, where K is given to be a natural number. If D1, D2, D3 represent the perpendicular distances of points A, B, and C from the triangles PBC, PCA, and PAB respectively, then which of the following is correct? Now in this particular question, we have to compare D1, D2, and D3, right? And from the language of the question, it's very much clear that first of all, we have to find the equation of the plane containing 3 points A, B, and C. Now, if you are familiar with the concepts of three-dimensional geometry, then you must be knowing, if suppose A is the point x1, y1, z1, B is the point x2, y2, z2, and C is the point x3, y3, z3, then we can directly write the equation of the plane containing these 3 points A, B, and C as x minus x1, y minus y1, z minus z1 in the first row of a determinant, and in the second row we can write x2 minus x1, y2 minus y1, z2 minus z1, and similarly in the third row we can write x3 minus x1, y3 minus y1, z3 minus z1, and put this determinant equal to 0. When we solve this determinant, we'll be getting an equation, and that equation will represent the equation of the plane containing the 3 points A, B, and C. Fine. We'll be using this equation repeatedly in this particular problem. Now first of all, let me find the equation of the plane containing A, B, and C. Now what I'm going to do, I'll be writing x minus, what is x1 here? I'm taking x1, y1, z1 as the coordinates of A, x2, y2, z2 as the coordinates of B, and x3, y3, z3 as the coordinates of C. Fine. So the equation is going to be x minus 1, then y minus 2, then z minus 1. And in the second row, I am going to write x2 minus x1. So it is going to be minus 2, then 1, then 4 minus 1, which is 3. And similarly, x3 minus x1 is going to be 0, then minus 2, and lastly, we are going to have 4. Fine. So let us simplify this equation now. Now, when we simplify this equation, we will be getting x minus 1. I am just expanding the determinant into 10 minus y minus 2 into minus 8 plus z minus 1 into 4. I am expanding it along the first row equal to 0. Right? Now just do the calculations. Now this is the equation of the plane containing the points A, B and C. Fine. And we are given that the point P is K, K minus 1, K minus 2. And it is situated at a distance of 10 upon 3 root 5 units from this particular plane. And we know that the formula to find the perpendicular distance of a given point from a given plane is modulus of ax1 plus by1 plus cz1 plus d divided upon under root a square plus b square plus c square, right? Where ax plus by plus cz plus d is equal to 0 is the equation of the plane, and the coordinates of the given point are x1, y1 and z1. So I'm just directly using this formula and equating this distance equal to 10 upon 3 root 5. So I will be getting 5k plus 4k minus 4 plus 2k minus 4 minus 15 upon, I'm taking the modulus of this, upon under root of a square plus b square plus c square. So this is a, this is b and this is c. So you'll be getting 25 plus 16 plus 4 equal to 10 upon 3 root 5, right? Now this square root contains 45 because 25 plus 16 plus 4 is 45, and when we simplify square root of 45 we'll be getting 3 root 5. So this 3 root 5 and 3 root 5 on the other right hand side, both of them cancel each other, and finally we get an equation modulus of 5k plus 4k, 9k plus 2k, that is 11k, minus 8 and minus 15, this is minus 23, equal to 10. And let us remove this modulus sign now. We'll be getting two possibilities. One is 11k minus 23 equal to 10. From here we'll be getting 11k equal to 33 and k equal to 3, right? This is one of the possibilities. And another is 11k minus 23 equal to minus 10. Fine. From here we'll be getting 11k equal to 13. And finally k becomes 13 upon 11. But if you read the question properly, it's mentioned that k is a natural number. So that means we have to reject this value. Fine. This particular value we have to reject. And now we are just having the value of k as 3. Now we move further. Now, since we have got the value of k as 3, so the coordinates of p come out to be 3 comma 2 comma 1. Fine. And it's given that d1 is the distance of the point A from the triangle PBC. Now distance of the point A from triangle PBC is same as the distance of point A from the plane containing PBC. Plane containing the points P, B and C, right? So what I'm going to do now, I will be writing the equation of plane containing the points P, B and C, and then I will be finding the distance d1. Okay. Now first of all, let us find the equation of plane containing the points P, B and C. Now again I am going to use the same equation. So it is going to be x minus 3, y minus 2, z minus 1. Same equation means the same formula we are going to use here. So it is x minus 3 because I am considering 3, 2, 1, the coordinates of P as x1, y1 and z1. Fine. And the coordinates of B as x2, y2, z2, and the coordinates of C as x3, y3, z3. Now in the second row I am going to get minus 4, 1 and 3. In the third row I am going to get minus 2 and 4. And this determinant I am going to put equal to 0. Now when we do the calculations, I am just expanding it along the first row. I will be getting x minus 3 into 10 minus y minus 2 into minus 10 plus z minus 1 into 10 equal to 0. Just divide throughout by 10. You will be getting x minus 3 plus y minus 2 plus z minus 1 equal to 0. Or in other words, this equation is just x plus y plus z equal to 6. Fine. And you can clearly see we have got the right equation because the coordinates of P as well as B as well as C, all the three satisfy this equation. Now we have to find the value of d1. And the coordinates of A were given to us as 1 to 1. So now I'm just directly using the formula to find the perpendicular distance of a point from a given plane. So d1 comes out to be modulus of 1 plus 2 plus 1 minus 6 upon under root of 3. So this finally becomes 2 upon root 3, right? This is the value of d1 which we have got. Now we move towards finding the value of d2. And similarly, we'll have to find d3, and then finally we'll make the comparison between all the three. Now to find the value of d2, first of all, I have to find the equation of the plane containing P, C and A. Fine. Now we find the equation of plane containing the points P, C and A, right? And that is going to be determinant. In the first row I am going to write x minus 3, then y minus 2, then z minus 1. In the second row it is going to be minus 2, then minus 2, then 4. In the third row it is going to be minus 2, then 0, then 0. Let's expand this determinant along the third row because it's very simple. So it is minus 2 into 4y minus 8 plus 2z minus 2. And the final equation comes out to be 2y plus z equal to 5 because it is going to be 4y plus 2z equal to 10. So I'm dividing it throughout by 2. Now we have to find the perpendicular distance of the point B from PC and A, and that is going to be D2, right? And the coordinates of B are given to us as minus 1, 3 and 4. So it is going to be modulus of 6 plus 4 minus 5 upon square root of 2 square plus 1 square, that is root 5. So finally it is going to be 5 upon root 5 or just root 5. Fine. Now this is d2 and you can clearly see 2 upon root 3 is smaller than root 5. Why I'm saying this? Because if I just multiply both sides with root 3, I'm going to get 2 less than root 15, which is correct. This is obviously true. So that means I can declare d1 is smaller than d2, right? Now, finally, we have to find the value of d3 to reach at the final answer. Now we find the equation of the plane containing the points P, A and B. And finally, we have to evaluate the perpendicular distance of the point C from this particular plane, right? Now, the equation of this plane is going to be determinant. First row will contain x minus 3, then y minus 2, then z minus 1. In the second row, we are going to have minus 2, then 0, then 0. And in the last row, we have minus 4, then 1 and 3 equal to 0. Now, obviously, we'll have to expand it along the second row because it contains two zeros. So it is minus 2 into minus, that is 2, into 3y minus 6, then minus inside the bracket z minus 1. So it becomes 1 minus z. And finally, we are getting 3y minus z equal to 5, right? And the coordinates of C are 1, 0, 5. So D3 comes out to be modulus of 3 into 0, then minus 5, then minus 5 upon under root of 3 square plus 1 square, which is nothing but square root of 10. So it is 10 upon root 10, or finally it is root 10, right? Now students, it's very much obvious that D3 is greater than D2 because D2 was square root of 5 and D3 is square root of 10. So obviously D3 is greater than D2. And earlier we made the comparison between D2 and D1 and we found D2 is greater than D1. So finally we can conclude D3 is greater than D2 greater than D1. So that means our C option is the correct option. Now it was a nice problem based on the basic concepts of three-dimensional geometry. Now we move to our last problem of this video. Now students, this is our last problem of this video and a really interesting one. The question says 10 horses H1, H2, H3 and so on up to H10 participate in a race tournament consisting of 10 rounds. Then the probability that horse H3 stands in any one of the top 3 positions in exactly 5 rounds that are not all consecutive is. Now clearly this question is based on the concept of binomial probability distribution. Now if you have done good practice on the problems of probability, then you must be knowing that if the probability of success in a single trial of an experiment is P and the probability of failure is Q, and suppose out of n trials if we want R successes, then according to binomial probability distribution the probability of R successes will be equal to NCR P to the power R into Q to the power n minus R, right? Now suppose if we remove this condition that these outcomes are not all consecutive, that means we will be getting 5 successes, any 5 successes out of these 10 rounds. We are not considering whether they are going to be all consecutive or not. Then according to this, if suppose I take the value of R as 5 because I want 5 successes, and what is success over here? success is that the horse H3 stands in any one of the top 3 positions in that particular round, right? Now, let's consider H3 comes in top 3 positions. So that means among the top 3 positions, I have to select any one. That means 3C1. Because among any of these 3 positions, H3 will come. And we are now left with other 7 positions. So that means the other 9 horses will come or stand anywhere among the leftover 9 positions. So that means basically we have to permute 9 horses among 9 places. So it's 3C1 into factorial 9. Fine. And if we find the exhaustive number of cases, that means if we remove this condition that H3 has to come in any one of the top 3 positions, then the total number of cases for this event are going to be factorial 10, right? So that means if I now calculate the value of P, that is the probability that horse H3 stands in any one of the top 3 positions in a particular round, then it is going to be 3C1 into factorial 9 because it is the total number of favorable cases and divided by total number of exhaustive cases. So it becomes 3 upon 10. So finally, P is equal to 3 by 10. And we know that P plus Q is equal to 1. So that means Q will be equal to 7 upon 10. Fine. Now we move further. Now suppose if I want to find the value of Px equal to 5, means I want to get the probability that out of these 10 rounds, horse H3 will stand in any one of the top 3 positions in exactly 5 rounds. Now these rounds may be consecutive or may not be all consecutive. So then that is going to be 10C5 3 upon 10 to the power 5. I'm just using the direct formula into 7 upon 10 to the power 5. Fine. So it comes out to be 10C5 into 21 upon 100 to the power 5. Now if we further simplify the value of 10C5 as factorial 10 upon factorial 5 into factorial 5, then after doing some calculations like this, we will be getting it's going to be 36 into 7, so it's 252. 252 into 21 upon 100 to the power 5, right? Now, our question is not this one. Our question is to find the probability that horse H3 stands in any one of the top 3 positions in exactly 5 rounds that are not all consecutive. That means out of this particular probability Px equal to 5, I will have to subtract the probability that all these rounds are consecutive. Now, if all these rounds are consecutive, then that can happen in only 6 situations. Like the horse H3 may stand in top 3 positions in the first 5 rounds or may stand in the top 3 positions in the next 5 rounds because all of them are consecutive, and so on till the last situation, that is 6, 7, 8, 9 and 10. So that means now if I want to get the probability for this situation, it is going to be 6 into 21 upon 100 to the power 5. Fine. Why I am writing 6 over here? Because there are only 6 such situations, and for each such situation the probability is going to be 3 by 10 to the power 5 into 7 upon 10 to the power 5. Now finally our answer is going to be required probability that horse H3 stands in top 3 positions in exactly 5 rounds, such that all these 5 rounds are not all consecutive. It is going to be 252 into 21 upon 100 to the power 5 minus this second probability, that is 6 into 21 upon 100 to the power 5, because now we are removing the unwanted cases, and the final answer comes out to be 246 into 21 upon 100 to the power 5. Right? Now it's a nice problem. I hope you must have understood this question. Now students, I will be putting another video on the problems of my book. Very soon I'm going to give you that video also, and I hope you are practicing these questions, and if you are really liking these problems, then please subscribe my channel and share these videos among your friends. Thanks.